have Dr. Rob Myers, who is with the regional representative for the USDA SARE program in the North Central region, and is also adjunct faculty here at the University of Missouri. So please welcome Dr. Rob Myers.
Thank you, Gregory. Well, good afternoon. Glad to be here with you today, and it's been exciting to hear about all the efforts that are going on with soil health. Many of you work in this area, but for those of you that don't, and you're just kind of coming to learn a little bit about soil health today, I will tell you, having worked in this area for several years, it's really amazing traveling across the country to see the enthusiasm and the level of activity. I was saying to somebody yesterday, it used to be in agronomy extension, which is my background, agronomy, you'd go to a farmer meeting and you'd have 20 people there. And now you go to a meeting on soil health or cover crops and you'll have 200 people there. So that's just one small example of the difference. But one thing we've done through my office, which the SARE program is the Sustainable Ag Research and Education Program. If you're not familiar with that, we're a program funded through USDA at about $27 million a year. And we give out funding to a variety of different groups, universities, nonprofits, and very importantly, directly to farmers to try new ideas related to sustainability, much of which is cover crops and soil health. I would say probably 20 or 25% of our portfolio every year is focused on soil health related activities. So one of the activities we do through my office is fund a national survey on cover crops. And that is kind of a good example to track what's happening with soil health. So I'll show you a few examples from that as we go through, as well as talk about some of the other trends that are going on. The National Survey of Cover Crops started in the drought year of 2012 because we started hearing about farmers who were experiencing something rather remarkable. Normally with cover crops, you go back several years ago, there was an assumption if you had cover crops growing, these are several different ones on a farm in Pennsylvania I visited, that those cover crops, because just like any plant, they're evaporating or transpiring moisture, that if you're going to grow a crop after them in a dry year, that's going to be bad, right? These cover crops would have used up all the soil moisture, and that would be negative to crops like corn and soybeans. But we started hearing from farmers that that was not the case. So we really wanted to document that, and you'll see some of the results of that here in just a moment. One of the things we tried to track through this national survey is just what's really happening with acreage. Again, cover crops is one of the indicators for what's going on with soil health. Obviously, there's other soil health practices, but this is one of the core ones we see. And obviously, the trend is very strong in the direction of continued growth. This is from about 2,000 farmers nationally filling out this online survey. And it's been about a 15% growth rate per year. In fact, when we started the survey 5 years ago, we were surveying back to about 2008, and the trend has just been up, up, up every year. The last bar for 2017 was projected acreage because this survey was from a year ago, I'm showing you today. And again, just amazing growth considering other agronomic management practices. So one of the reasons farmers historically have used cover crops is soil erosion, or maybe to provide some fertility. We used them on my family farm that I grew up on in Illinois. My dad was using them in the 1960s to help provide some fertility ahead of corn. And as we look at erosion, we see even places where we have terraces, we still see erosion. So some of the research is now showing that if we add cover crops to a landscape with buffer strips and with terraces, that can cut erosion by up to 99%, especially combined with no-till practices. And so that's a huge impact in terms of keeping not only the soil, but fertilizers and pesticides in place in the field. But one of the myths we've exploded about cover crops and soil practices is that farmers are only doing them because they're getting paid to do them. We had a meeting here on the campus yesterday talking about how some different agency programs are impacting these soil health practices like cover crops. And in Missouri, we know we're now cost sharing over 200,000 acres of cover crops. But this survey shows, if you see the purple slice, that 63% of farmers are not receiving any payments to do cover crop practices. And only 8%, that little slice right there, were always receiving payments to do that practice. So clearly the majority of the farmers are motivated by other factors. We had a few that said, yes, I initially received some cover crop cost share, but now I do it on my own. And I've heard that from many, many farmers. So again, in Missouri, about 200,000 acres currently or more cost shared, but probably around 700,000 or more actually being planted out of about 10 million row crop acres. One of those reasons is that cover crops do provide so many benefits. You heard a bit about this earlier today, and again, this is just one of our sets of soil health practices. But we came up with this illustration to just show it's a versatile tool, like a Swiss Army knife, that can provide a lot of different benefits. We have farmers with issues, obviously, with erosion, like was mentioned. We have farmers with soil compaction from driving big equipment across it. Of course, there's new interest in pollinators and beneficial insects. Weed control is a big issue, and I'll talk more about that in a minute. But it all comes back really to improving soil health when you put these practices together. If we ask farmers what is the driving force, just like the previous slide showed, really the bottom line is improved soil health. Again, used to be erosion control probably would have been the preferred thing, but we still see a lot of interest in organic matter. But those three together really comprise the driving forces for this particular practice. Okay, I'm just going to use this thing, I think. And one of the things that is of interest, we heard a few people talking about what's happening with tillage. So when we talk about continuous no-till, this green slice at 41%, these are farmers that never disturb the soil. And that's one of the 4 core principles of soil health, is minimizing soil disturbance, along with keeping the soil covered, improving diversity, and so on. That continuous no-till is strong in Missouri as well, but we also have farmers that do something called rotational no-till. And typically what happens is after soybeans, which don't leave a lot of leaves and stalks on the ground, they'll come in and plant directly into that without any tillage. Usually they'll be planting corn. But maybe after corn, which leaves a lot more stalks and leaves, they'll come in and do a little tillage after that. So that's what we call rotational tillage. We also see another 27% that are reducing their tillage, but about 14% still conventional. Now you might be surprised there would be that much. Some of that, in the case of the survey, is the horticulture farmers, because about 20% of the farmers we surveyed were horticultural producers. I mentioned in the drought year of 2012, we saw some pretty unexpected and striking yield benefits. If you look at that line of 2012, you see for corn there was just under 10%, and for soybeans just over a 10% yield increase. Now this was several hundred farmers providing data, and we asked them to only give us data if they had some fields with cover crops and some without, with otherwise similar management. In other words, the same varieties, similar planting date, and so on. So that was a pretty striking difference, that there could be that much of an advantage in a dry year when that cover crop, in theory, might have been stealing moisture from the cash crop. In the subsequent years, the yield increases have been more modest, as typically there's been more rain across the Corn Belt, 2 to 3% for corn, 3 to 4% for soybeans. So what's going on? Well, there's many things that can happen that can contribute to yield benefits when we talk about soil health and cover crops. One of those is if we take something like soybeans year after year, which we have in Missouri, because we have over 5 million acres of soybeans, less than half of that of corn. If you grow in between those 2 years of soybeans, you grow some cereal rye. In theory, that rye is a cover crop that roots fairly deeply. It will root perhaps another 6 inches deeper than the soybeans. And then we know from research what happens is that the crop the next year, those crop roots tend to follow the same root channels created by that previous set of plants. So if the rye is growing 6 inches deeper, some of those soybean roots will get down deeper as well. And that means they can go deeper to get more moisture and get more nutrients. So that's part of the reason we see a benefit in a dry year following cover crops. We also have this residue on the surface. Some of that rye residue is going to stick around for a while. That's going to reduce evaporation for the soil. So that's one of the things that's going on. We also know that when we have a cover crop, well, first of all, if you just look at these two pictures, you can guess which one's going to have more earthworms, right? So it's the one on the left where we've got a cover crop. This has been shown through research that you'll get significantly more earthworm activity and a greater diversity of earthworms where you have those cover crops. And what happens to also help with the dry year is those root channels from the cover crop and the earthworm channels help get the rain into the soil. That infiltration keeps the water from running off, and that can be dramatically different. If we go in and till that soil, we could start to lose those benefits. So that's why it's really good to combine cover crops with no-till, is so that we can keep those macropores there, keep that soil structure. Now, another thing that happens with these earthworm channels is they're really highly fertile areas of intense activity for roots to follow. So as those earthworms are going along, they're creating a very fertile zone next to that earthworm channel, and the roots will naturally follow that to take advantage of that. Some people say earthworms are like soil engineers. They're moving nutrients around in the soil, providing us lots of benefits. So again, this is helping with a dry year situation. As we look at corn, for example, or really any crop, another thing that can happen that is a benefit in a dry year is mycorrhizae. Mycorrhizae are a type of fungi in the soil that can associate with plant roots, and they actually are doing that with an interesting exchange going on. Some people talk about this as the underground carbon economy. So the plant roots will exude sugars or carbohydrates that the bacteria and fungi in the soil take up, especially the mycorrhizal fungi, and in return, those fungi are making certain nutrients, particularly phosphorus, more available to the plant roots. They can also help make moisture available to the plant roots, so it's an interesting trade of sugars or carbon to these organisms in return for helping with nutrients to the crop roots. So that too can help the crop in a dry year. And there's other benefits that we think are happening. So residue, preventing evaporation, getting more rain into the soil, deeper roots, more fungi helping with root surface area and exposure, all those things benefit in a dry year. So when you look at this from the standpoint of resiliency, you heard people talking about that this morning. Wayne Honeycutt mentioned the importance of resiliency as we face more droughts. We asked farmers, what do you think about resiliency? And you can see that about 2/3 of them thought that there was more resiliency by having a cover crop out there. Now about 28% felt neutral, but not very many disagreed with that idea. So this is an important thing as we look at policies like crop insurance. Farmers, we're transferring billions of dollars in crop insurance payments to farmers each year. Should we somehow be factoring these conservation practices into the way crop insurance payments are made? What about profitability? Yield is one thing, but in the end, you have to pay money to grow that cover crop. So do you still lose money even though you're getting a yield increase? Well, we asked farmers to look at that. We found that about 33% said that cover crops were, definitely improving their profitability. About 26% said that there was no change. We only had 5.7% said that it was decreasing profitability, and about 1/3 weren't sure, just didn't have enough data yet. We've looked at other numbers besides this, and I think the thing we would say is probably in the first year of using a cover crop, not necessarily a profit increase, but as we get to the second and especially third year and beyond, then that profit increase starts to kick in. This is something we surveyed for the first time this year, is what was going on with herbicide-resistant weeds on the farm. And I was a little surprised to see that over half of farmers are now saying they've got herbicide-resistant weeds. This used to be more of a problem on southern farms, but these weeds have been becoming a problem increasingly all over the Corn Belt. And this is what it can look like. I saw field after field like this driving across the Midwest this summer, much more than I ever have before. This is herbicide-resistant Palmer amaranth. There are other weeds that are commonly becoming herbicide-resistant. So typically this is resistant to glyphosate, our most common weed herbicide product used, or Roundup, you might know it by the trade name. But there are other products that these weeds are becoming resistant to. So they're really becoming a challenge, and they can really choke out the crop and make for a much reduced yield. So we asked farmers, if you're using cereal rye, because that's been known to have some allelopathic benefits to certain weeds, does that really help with some of these herbicide-resistant weeds? So you can see the green slice, 25% said yes, that it always provided a benefit, and another 44% said sometimes, probably depending on how much rye growth they had, how they managed it, and so on. So not in every situation, it's not a perfect tool to control these very tough weeds, but it's another tool in the toolkit for farmers. And I've heard many say that if they use this in combination with their herbicide practices, they get excellent weed control. This is another thing that's kind of coming into play that also affects weed management, but just the overall soil health as well. And this is the idea called planting green. There are a couple quick references to that earlier today, but if you're not familiar with that practice, seeing a picture like this, if you've ever been around farming, might surprise you a little. So this is a farmer out planting soybeans. Now, if you had shown me this picture maybe 8 or 10 years ago as an agronomist, I'd said, that doesn't look like a very smart idea to go out and plant soybeans into what is 4 or 5 foot tall cereal rye. But increasingly, farmers are doing this practice. So why are they doing that? Why are they letting that cover crop keep growing? We found, that, first of all, that about 40% have now tried that, and that number is going up every year. I just saw a new survey by No-Till magazine, and over half of their farmers have tried this planting green. And this is what happens. So the farmer keeps the cover crop growing green, and then after they plant their crop, like their soybeans, they go out and spray it. And you heard Francis Tickey, if you were here this morning, mention that. So here's some soybeans starting to come up through the rye residue. It's been killed by a herbicide after planting the soybeans. Weed control, again, 61% said that when they do this planting green, they let the cover crop grow longer, produce more biomass, they're getting better weed control. So you can imagine with that 4 foot tall cereal rye, that is much more suppressive of weeds than if you had 4 inch tall cereal rye. About 31% said it was unchanged, 8% said a little more challenging, but overall, clearly, most are finding a net benefit. Then we asked, how about moisture? There's been concern, again, especially among crop insurance folks, well, if you let that cover crop grow for so long, isn't that going to be bad for your corn or soybeans? We actually found 62% said that helped with moisture management. Now, how can that be? You're letting that cereal rye grow 4 feet, 5 feet tall, and you're saying you've got a better moisture situation? Well, we saw some climatology data earlier. The climatologists are now telling us in most of the Midwest, our springs are wetter than they used to be. Our late summer is getting drier, but springs are getting wetter. And so farmers are having trouble getting in the field when it's too wet in the spring. If they keep that cover crop growing in a wet spring, it will, in fact, of course, transpire some of that moisture. Plus, they've got better soil structure. That residue, it all contributes to being able to get in that field and plant when maybe they wouldn't otherwise be able to. Only 11% of the farmers said it was drying the field out too often. So this was a surprise, I think, to a lot of folks. The motivations for doing this practice, planting green, most of them it's to maximize cover crop use, this bar on the left. So this comes back to soil health. If we can have 4 feet of cereal rye biomass or other cover crops, that's much better than just a few inches of cereal rye, which is kind of the older thinking. Probably several years ago, we'd say, well, kill that cover crop, very early in the spring, get it under control, get it out of the way so you don't have to worry about it. But our thinking is starting to change on this. And of course, if we let that cover crop grow longer, then we've got more residue. So this is some cereal rye residue in between soybeans as they're growing. And here we come back to soil health once again. That residue is not only helping suppress weeds, but it's creating a moister soil surface and a cooler soil surface. And both of those are a plus for bacteria and fungi and other organisms in the soil. So we find we have a much healthier soil ecosystem with that residue mat in place. Well, I mentioned planting a cash crop like corn or soybeans into a cover crop. Let's flip it around. Let's go from the spring to the fall. So how are farmers seeding their cover crops? Because this is changing as well. A lot of farmers have flown on their cover crops. That allows them to get the cover crop started early. So here they're doing it onto a field of soybeans just as they're starting to turn yellow. This in Missouri could be late August, early September, depending on where you're at. And that way maybe you can get an extra month of growth on that cover crop or at least an extra few weeks. If you look overall at what we found from the survey, about half of the farmers are still going out after harvest though, using a grain drill to plant these cover crops. We also found a variety of other approaches. We found that about 14% were using an airplane, others were using other broadcast methods, so again, a diversity of approaches. But we're seeing innovation in equipment. Here's a high clearance cover crop interseeder. So they put the seed back here in a box, and then it's blown by an air blower out through these long tubes comes down these plastic tubes and hits a little metal diverter, and that causes it to be spread out into the corn canopy. Now, this is not in some ways a whole lot different than an airplane, except you can do it on a windy day, which you can't with an airplane, and it doesn't lead to the cover crops getting in the neighbor's field, which can be a good thing sometimes. But most importantly, it creates a way for the private sector to get more involved. We've got a lot of companies that are out there helping farmers with fertilizers and pesticides that use equipment like this. They can take the same machine that they're normally spraying fungicides, spraying herbicides with, in about a half a day convert that over to spray or to spread cover crop seed, and they can pay for that change in equipment in a single fall. And then after that, every year it's extra income. And their equipment and their staff are not as busy at the time cover crops need to be seeded. Usually August and September are relatively slow periods for those companies. So we're starting to see more of these companies get involved in the cover crop industry. We're seeing farmers use more mixes of cover crops. We mentioned earlier today, folks talked about biodiversity above ground equals biodiversity below ground. So this is a mix of hairy vetch. You can see a few purple flowers in there, crimson clover, and some cereal rye. This is a mix I sometimes use in my garden or I've used on fields, and a very popular one for farmers. We find that farmers say they're using a variety of mixes. Some are using two-way mixes. As you see here, they were projecting to increase that from 2016 to 17. Three-way mixes are another approach. And then we see the most popular being using 4 or more mixes. We heard Josh Payne talk earlier that after wheat, he plants a multi-way blend of cover crops, maybe 8, 10, 12 species of cover crops. And that has its pros and cons, but definitely for soil health, it's a good thing. So how do we get diversity in the rotation besides just mixes of cover crops? Well, one thing we're starting to see, and Josh is a good example of this, is cereal rye works really well before soybeans, but not quite as well before corn because of some nutrient tie-up issues. So maybe we have farmers that say, well, I want something that's not going to create that nutrient tie-up issue. So maybe I'll use oats and or radishes. Those will winter kill. They'll be out of the way. They're not going to be a problem for corn. However, then it's nothing growing over the winter. We want to keep those living roots going year-round. So maybe as they get some experience, then they'll put in an overwintering cover crop like crimson clover, but still as a legume, not something that's going to tie up their nitrogen before corn. So we're starting to see farmers do things like this, where they implement a blend of different cover crops from season to season. But we also see the approach Josh was using, which he mentioned, Dave Brandt, a farmer in Ohio that's well known in cover crop and soil health circles, where it's corn and soybeans, but they go back to something they used to do, which is adding winter wheat. I mentioned on the farm I grew up on, we had cover crops, but only until wheat left the farm, and that was in the late 1960s. We had something very similar to this, corn, soybeans, winter wheat. We would put in legumes overseeded into the wheat. They would grow all summer, all fall, into the spring. Then they'd be plowed in before the corn to provide fertility. But we took wheat out of the operation because it wasn't as profitable, and then that affected the loss of cover crops from a lot of farms. So now we're seeing farmers go back to adding wheat so they can get a diverse mix of cocktail cover crops in there. That seems to help build organic matter faster than just about any other approach, and it creates some great opportunities to graze with cattle as we go out there. There's been research in Missouri and other states. Rob Cullenbach did a lot of work on this, showing that a variety of different cover crops, including triticale, wheat, cereal rye, can all be great grazing sources for cattle. The cattle will gain weight faster in the fall and early spring on cover crops than they would maybe on a tall fescue pasture. Of course, it depends on the conditions. And you want to do this with intensive management grazing, but we're seeing more and more farmers do this. Now, when we come back to soil health, what's important about this is that we've got those cattle, their manure, their urine, their saliva, they're stimulating the soil bioactivity when that's out there across the landscape. So I wanted to kind of just end up looking at some of the projections and economic numbers. I said about a 15% growth rate is what we've had. We know from the census in 2012, which was the last thorough snapshot of acreage, we had 10.3 million acres. Going forward, we think we're going to be to about 40 or 50 million acres in the next 7 years. So that's going to start to be more and more on the landscape. we think we'll go from this situation where you see just an isolated field. This is a farmer friend in Iowa sent me this Google Earth map, the only farm that had cereal rye on it. And another farmer friend sent me this from Pennsylvania. In his county, about 70% of the farms have cover crops. He actually sent me a whole bunch of aerial photos, and they all look like this. And you might think, well, that's just wheat. Well, I looked up in that county, only 3% of the acreage was wheat for grain. So these are cover crops. I mean, that's pretty amazing, the landscape just being covered like that. And there are other parts of the country starting to be this way. So in the end, we're trying to get the land to be green, have those living roots year-round, as Mike Gold mentioned as we started today. And in the bottom line, if we can keep those living roots in the soil, keep capturing that sunlight, building biodiversity, we're going to build our soil health going forward. So thank you.
Thank you, Rob. We do have a few minutes to take a few questions, so if there were any questions from the audience, please. We have people circulating the mics. Yes.
That's a great talk.
Thank you.
I had a comment on the, when you talk about the mycorrhizal fungi, they've been doing quite a bit of work where they found out any kind of tillage, when you're trying to get fungi in your crop fields, it just wipes it out. So I think people ought to be aware of that. If you're going to try and till, you're not going to have any fungi.
That's right. So you think of these fungal hyphae kind of growing through the soil. Any disturbance of that's going to, either kill those completely or really set them back, because you're basically tearing apart those fungi with that disturbance. Much more of an impact than just what we'd see on the bacteria, but really all of our soil organisms are impacted. But we do see the more tillage, the more we shift from fungal biomass to bacterial biomass. And there are good bacteria and bad bacteria. There are good fungi and bad fungi, but overall we like those mycorrhizal fungi. So good point. Yep.
Yeah, my question is about using the roller or crimper to terminate your cereal rye or your winter cover crops. It seems like in a lot of cases farmers have to crimp and then also spray, I guess as an assurance of terminating their cover crop. And I know you've seen a lot of different examples, but I'm wondering what is the challenge? Why isn't the roller crimper terminating the cover crop? And why is it necessary to spray after crimping?
Right. Well, I would say most of the time people use a roller crimper, they are not spraying a herbicide, but you are correct, occasionally they are. It just kind of depends on their management. If the soil is really wet, like from a big rain, and you come in and try to use that roller crimper, it's going to push that stem kind of down into the mud. It's not going to do its crimping action where it's breaking the vascular tissue in the stem that really kills that. If you've got a really thick biomass, it can also sometimes be a little difficult to terminate it. But usually the failures with a roller crimper are due to timing, that they're trying to roll it too early. Usually we want these plants to be reproductive. So the other thing is you don't necessarily need a roller crimper, sometimes just knocking them down. I see Tim back there in the back. He's had experience trying to kill these cover crops every way possible. And Tim, you'd probably say just even the planter bar sometimes can knock it down enough to do a lot of good. But it's a trade-off, either spraying or using roller crimper.
There's one question there. Go ahead.
So I know one of the reasons people use cover crops is to increase the soil activity, the microbiome. I'm wondering what you found is the effect of using synthetic fertilizers and chemical pesticides, herbicides on that microbiome of the soil.
Well, there's a lot more that we don't know than we do know, but there has been some research. Bob Kramer, who's a retired soil microbiologist, was here earlier. Bob, are you still here? I don't see him. He has done research on glyphosate's impact on soil microbes, found that there can be some impacts. We know if we put on synthetic nitrogen that especially as anhydrous ammonia, is probably the one that has the most impact on soil microbes. Generally, the feeling with things like anhydrous ammonia is a lot of the organisms bounce back pretty quickly, like the bacteria, because they divide so fast that you may kill a lot of them for a few days, but then they'll start to bounce back. I was looking for Peter Scharf, because he would be more the expert on that. Peter, what's your opinion on that? When we put on synthetic fertilizers, what happens with the microbial community? He's our soil fertility expert, by the way, at the university.
With the banded fertilizer like anhydrous or banded liquid, the volume that's affected of the soil is very small, even at the beginning. So it's it's like a couple percent, and everything else is more or less undisturbed. If you broadcast, you're going to affect more of the soil volume, but with a much less dramatic effect on the rest of it. But overall, I think there's the main shifts are because of the increased plant growth. You get, and if you have some other way of making the plants. The differences in microbes between fertilized and unfertilized are mostly because you got a lot more plant growth where you fertilized. If you have some other way other than fertilizer of putting it there, you're going to get the same changes.
I guess another way to come at that is if we have a healthy soil, we're getting cover crop residue in the soil, maybe we're adding manure, we've got a diverse rotation, that's going to lead to a more diverse biological community, and you're going to see more nutrient cycling in that root zone. So it's not just simply the chemical action of the fertilizer on the microbes, it's kind of the whole system you're creating in the soil. But good question.
I think we can take one more question, and then please go ahead.
How significant is the mycorrhizal fungi community in a no-till crop field?
Well, it's benefit in any type of system, but you're going to have much more of it in a no-till system than you are in a highly tilled system, as was brought up earlier. So it's really important because those mycorrhizae, again, they just play this amazing role where they're not only helping move phosphorus, which can be relatively unavailable in the soil. Most of the phosphorus in our soils is unavailable to the plant, just in the chemical form that it's in. Those mycorrhizae help put it into a biologically available form. They also do things that we don't totally understand in terms of communicating between not only plants that are adjacent to each other, but between the plants and other organisms. So there's a whole lot of things to be explored about mycorrhizae, but we just know when we see high levels of them that it seems to do really good things for the plants, would be a really simple explanation. Okay, well, thank you.
Yes, I think, thanks so much for the questions. Thank you, Rob, for the great presentation. Yeah.